Okay, now I would like to go over dividing monomials. We previously did multiplying monomials. This is a continuation on that. And again, I'm going to assume that you know what monomials are. And for dividing monomials, you need to keep in mind a couple of rules. The quotient rule, which says that, quotient rule, which says x to the a power divided by x to the b power is going to equal x to the a minus b. That was the quotient rule. And also we had a distributive rule for fractions. So if you have a over b, this is raised to some n power, the n exponent is going to be distributed to both a and b. So that's going to equal a to the n over b to the n. So let's keep these rules in mind as we work through a few examples of dividing monomials. So let's start off with something easy. Let's say we have 15a cubed divided by 5a squared. Now, very similar to multiplying monomials, when you're dividing monomials, you can treat the numbers and the letters separately. So the numbers are going to equal 3. The letters are going to equal a cubed and a squared. Using the quotient rule, that's just going to equal a to the first power or just a. Now this is a simple problem, so we could just find our answer like this. But sometimes our problem gets a bit more complicated. For example, if we have 12a squared divided by 6a to the fourth. Now this doesn't look that complicated, but the tricky part is we have a smaller power in the front and a bigger power in the back. So I think an easier way to do division problems is to change them to fractions. So let's change this to fraction. 12a squared, we're just changing the division sign to a fraction bar, like this. And now you can see where our leftover a will end up. So again, looking at the numbers, we can reduce the numbers. So there's going to be 2 left over on the top and a 1 left over on the bottom. And for the letters, we have an a times a on top and a times a times a times a on the bottom. When you cancel 2 a's, there are going to be 2 a's left on the bottom. So it makes sense because there are more a's on the bottom. After we're done canceling, the 2 a's are going to be left over in the bottom. So when you visualize this as a fraction, it's much easier to see where the numbers and the letters are going to end up. From here, from our original question, it's kind of hard to see where the number and the letters are going to end up in terms of the numerator and denominator. So here, we are just going to have, notice that all our letters are canceled in the numerator. So we just have the 2 in the numerator. Our numerator is going to be 2. And our numbers are all canceled out in the denominator. So we're just going to be left with 2a's or a squared. Okay, so that would be our answer here. Okay, let's try another problem. Negative 6x to the fourth power divided by 2/3 x squared y. Okay, the reason I've introduced this problem is because there's a hack you can do when you see a fraction in a division problem. So before you do the hack though, you'll need to change this whole thing to a fraction. So let's just move the x squared y to the numerator. Okay, so let's change this to negative 6x to the fourth divided by 2x squared y over 3. This is the same as this, by the way, for those of you who didn't know. We can multiply things to the numerator. We can't multiply the x squared y to the denominator, but we can do this. Okay, so once we have a fraction, we can change this to a multiplication problem. And the reason we want to change this to a multiplication problem is because usually multiplication problems are easier than division problems. So remember from arithmetic class, when you are doing 3 divided by 2/3, you can actually change that to 3 times 3/2, and that would equal 9/2. Okay, so we're using the same concept here. We have a number divided by a fraction, so we can change that to a multiplication. Let's not use an x as the multiplication sign since we have x's. Let's use a dot. And 3 over 2x squared y. Okay, so now we have multiplication, and it's easy to see how to cancel the numbers. So we can cancel the 2 here in the denominator with the negative 6 here. The negative 6 will become negative 3 when you cancel that with that. We can also cancel the x to the fourth power. We have 4 x's on top and 2 x's on the bottom. So we'll cancel that, we'll cancel this, and we'll be left with x squared because we canceled 2 x's. And we can't cancel anything else. We can just simply multiply them across. So we have a negative 3 and a 3 on the numerator, which will multiply to negative 9. We have an x squared on the numerator. And everything is canceled in the denominator except for y. So that would be our answer. Notice how our problem got a little bit simpler because we were able to change the division problem to a multiplication problem. Okay, so you can do that when there's a fraction or when you're dividing a number by a fraction. It doesn't matter if there are x's or y's, you can still use this method as long as you keep track of where the x's and y's are. Okay, let's do one last problem to kind of summarize everything that we've done here. One last problem. So let's have 4x squared y cubed divided by 2/3 x cubed y, and this is all raised to the second power. So if you remember from the multiplication of monomials, I've said that you need to simplify each of the individual terms first, and that goes with this as well. So let's simplify, because this whole thing is raised or is squared, let's simplify this. So let's leave the first part as it is. And notice we can use the distributive property and distribute the square to each of these terms. So distributing the square to the 2/3, distributing the square to the x cubed, and distributing it to y, which is going to be y squared. And we can now simplify these as well. Remember our distributive rule for fractions. We have to distribute the exponent to both the numerator and the denominator. So we'll have to distribute the square to both 2 and 3 here, in which case the numerator is going to be 2 squared, which is 4. The denominator is going to be 3 squared, which is 9 times. And here we can use the power rule. X cubed squared is going to equal x to the 3 times 2, which is 6. And then we have the y squared. And we still have the first term here. Divide by. Now remember what I said about dividing fractions. You can just flip the fraction. So let's do that here as well. And to do that, we'll need to change this to one fraction. Right now it doesn't look like a fraction. So let's move all of these letters to the numerator. So that will become 4 to the x6 y squared over 9. And we have 4x squared y cubed divided by this. Okay, our problem is becoming a bit more simpler. 4x squared y cubed. We changed this to multiplication, and then we flipped the fraction. So the 9 will go on top. The 4x6 y squared will go on the bottom. And now we can cancel a bunch of things here. We can cancel the 4 with the 4. We can also cancel the x squared and the x6. So there are 2 x's on top, 6 x's on bottom. So after we cancel, there are going to be 4 x's left on the bottom. For the y, there are 3 y's on top, 2 y's on the bottom. So after we cancel, there's going to be 1 y left on top. Okay, and then we can just simply multiply across. So on the numerator, we just have y times 9, which is 9y. And on the denominator, we have x to the 4th power. And this is our answer. Okay, so this process, it looked to be very complicated and very hard. But with practice, you can become much more comfortable. And try to do this piece by piece. Don't try to do everything at the same time. Write each of the process out. So in this case, I've distributed the power of 2 to each of the terms. And then I've simplified each of the individual terms further. I've made that into one big fraction. And then I flipped it and changed the division to multiplication. So just do them piece by piece, and eventually you'll get the answer. Don't be too discouraged that the process is too complicated. I'm sure with a lot of practice, you'll be much more comfortable with it.